Thank you. Let's see, do these mics work? Okay, cool. Thanks, good to see some familiar faces in here as well. So today's talk will be about web applications of the future. So if you've been to the workshop yesterday, then you see some familiar things, but now we have some more time to actually explain what's going on and why combining TypeScript and GraphQL is such a powerful combination. So I always like to start with this slide when I'm explaining TypeScript. So what is actually a date? So a date can be many things. It could be the date on the calendar. I believe today it's like the 30th, 31st? Oh, 30th. So yeah, it's a date on the calendar. So this could be a date. You could also have these actual dried fruits, which are also dates. Not really a fan of it, but I mean, it could be nice. And you could also spell the word date with these dried date fruits. So it's kind of, date can be basically anything. It can also be like something like this, like a still from a Disney movie. So date can be many things, especially if you work with JavaScript. You might have experienced different kind of dates, like strings, maybe date objects, maybe, I don't know, maybe even an object itself that was combined with like a day, a month, a year. So there could be many different things that you could call a date in JavaScript. I summed up some of them here. I always hate these timestamps because they're not really human-friendly. You actually have to use a library or some converter online to figure out what's going on. So date can be many things. And if you have a type system, you know one thing for sure. If there's a date somewhere, it will follow what's in your type system. Unless maybe you use a string as a date. I wouldn't do that, but you could do it. But with type systems, you actually avoid this problem of having all these different ways to define a date. And that's also why I like TypeScript. And GraphQL, of course, as well. As Beth introduced, my name is Roy. I'm from Amsterdam. Also very happy to be back in London. It's one of my favorite cities. I work with StepZen, which is a GraphQL as a service company. I also like to create my own side projects. The latest one is Reposted. If you like writing articles on Hashnote or Medium or Practical Dev, this platform can help you to redistribute them all over these different platforms. So it's kind of fun if you like to get more reach for all the hard work you do in writing blog posts. I also like to write books and go to conferences like this one. So last year was actually CityJS, which was my first post-pandemic conference. So, well, really happy to be back here. That about me. So what do you already know about TypeScript? Are there any TypeScript users in here? Oh, most of you, so I don't have to do anything today. That's fun. Yeah. So in case you don't know, and it's always good to hear this a second or third time, TypeScript is a typed superset of JavaScript. So if someone asks you if you're doing TypeScript, you can just tell them it's a typed superset. What does it mean? If you ask the internet, it is a programming language that contains all the given all the features of a given language. So you could assume everything you can do in JavaScript, you can also do it in TypeScript with some expansion stuff. So basically TypeScript is a expanded version of JavaScript with the static type checking and more actually if you count in all the developer tools you have. And it also compiles to plain JavaScript. So I sometimes funnily say I don't write JavaScript anymore. I sometimes do just because I have to for reasons. But in that sense, if you're writing TypeScript, you're still writing TypeScript. You're still writing JavaScript. You're just not writing it yourself. So as you already are familiar with TypeScript, we can go over this quite fast. So if you look on the left, you can see some basic type definitions. And you can also see a function that's using this type. And whatever would be prepared for your browser is what you see on the right. So unfortunately, most browsers can parse TypeScript themselves. They're actually working on a way to add type checking to JavaScript through some sort of annotations. And then if they will push it to the browser, they will actually keep those annotations in. But they're going to make sure that there is some sort of commented out. So you can still see them, or maybe your compiler will take them out. But well, it's good to know that whatever ends up in your browser is still JavaScript because, well, browsers don't really like TypeScript. And it also uses the latest ECMAScript feature. So this is sort of inherent to the fact that being a typed superset. So whatever is in JavaScript and is like in a stable release of ECMAScript actually. So we sometimes say JavaScript, well we actually mean ECMAScript in the other way around maybe sometimes too. But it always uses the latest features that are sort of stably released in ECMAScript. And if you went to the workshop yesterday, you know, but there's another technology that also has types, which is GraphQL, of course, as I really love GraphQL, basically also because of the type system, not only because I feel it's like a way better way to handle APIs as opposed to REST, but it also comes with a really cool type system that helps you actually to become a more productive developer, because this type system will really guide you. If you're using TypeScript, you probably already are familiar with like the performance gains you will get of having types. You no longer have to debug stuff in the browser or use console log to figure out what your data look like. With GraphQL, it's pretty similar. You also have the type system that will help you and guide you and make sure that you're more productive while also not pushing any stuff that could break into your production applications. So are there any GraphQL users here already? Okay, cool, that's a lot, that's great. So GraphQL is what I like to call a query language for APIs. So GraphQL itself is just a specification. It's not doing much. There's a whole bunch of libraries that form the ecosystem around the specification, but the specification itself, it's not a programming language, it's not a framework or a library. It looks a bit like this. As most of you have used GraphQL, you know what it looks like. I can imagine maybe in the back it's not really visible with the dark mode and the light on it, but well, you can get a sense out of it. So what you see on the left is a query, which is one of the three operation types we have. You can also see the fields I'm requesting and also the name of the operation field, which is GitHub user in that sense. And then you can see I'm requesting a set of fields, also some nested fields. And then the response on the right is whatever the GraphQL API would return to you, which follows the same structure, which is something I also like. It doesn't really have to do with the type system, but it's one way in which GraphQL helps you to become a better and more productive developer. So you can basically ask GraphQL the data you need. Of course, only data that is available in the schema. Otherwise, it would be pretty hard to get this data. And then your response should look pretty much the same. It's a bit like the Spice Girls song. If you're from the 90s, like myself, you probably heard their songs. So GraphQL is a bit like this. It will give you what you want, what you actually really want. So that's good to know. And then also it offers a single endpoint for multiple resources. So if you're using REST APIs, you probably hate that you need to send requests to multiple endpoints in order to get all the data for a page you're trying to render. At least that's one of the, well, the major issues I have with using REST APIs. Specifically, if you're using multiple REST endpoints, you need to collect data. You're maybe using a promise. You maybe wait till the promise is all settled before you have all your data. With GraphQL, you don't really have to do this, at least not on the front-end side. Maybe you do this on the back-end side if you're collecting information from multiple different data sources. But a single endpoint for me is a real advantage, because as a front-end developer especially, you don't really want to have to focus on where you get your data from or how it's loaded from different endpoints. You just want to get your data. So with GraphQL, and I've used the Twitter API for this actually before it became paid. I don't think I have the money to actually pay for an API key, as Daniel just told me how expensive it is, so I won't be trying to do that. But they have a REST API, and I've GraphQLized it in this example. You basically need two endpoints if you would want to receive a list of tweets and their author. So what happens? You first need to send a request to actually get the list of tweets, and then per every tweet there will be like a reference to the person that wrote the tweet, and you will need to send a second request to actually get this author. And you can imagine if you maybe have a list of like 100 responses. So for example, this week, if people start tweeting about City.js and I'm looking for a list of tweets that contain the word City.js, you might get a really long list. And if every tweet was created by a different person, you would maybe need to send for every request to the search API, which is one request, you might have to send 50 additional requests to get all the different authors in. And if you're all doing this from your front end, you can imagine it takes quite a while for all these requests to actually solve. So with GraphQL, on the backend side, of course, you can define these nested relationships. So you could say, I want to get all the tweets, including their author, and the GraphQL backend would make sure that it would retrieve this data. So maybe it's coming from a database, maybe it's coming from a REST API, maybe it's coming from, well, somewhere else. GraphQL itself doesn't really matter as long as you're using it from like a client perspective. If you're building the API, of course, you need to make sure that you set up all these connections in like a more efficient way. And then finally, which brings me to today's topic again, it's based on a type system. So everything you do in GraphQL will be type checked. If you're sending an operation to the API, it will check the types. If you're trying to create a response from your GraphQL API itself to the front end, it will also check again the types. And depending which library or framework you're using to build the GraphQL API, it will also do those type checkings whenever you're building or compiling your code. So the type system is, well, it's inside the schema, but most of the times you interact with the type system as a developer from a front-end perspective, you would be seeing it from a GraphQL playground. So it could be graphical, it could be any other GraphQL playground that's used by the tools you're using to build GraphQL APIs. And in there you typically have a documentation page or tab that will show you your schema. So for example, for the response type of this query, I have a response type called Twitter_tweet. I can see that I have these fields, and then I can also find the types for these fields. And sometimes you can actually click on them in case they're not like a leaf field. So in GraphQL, the leaf field is like a single response. If it might be a nested response, like an object, you can actually click on it and discover all the fields in there as well. And it's a really convenient way to get some insights into the API you're using. Whereas with the REST API, you're typically, it's typically in the hands of the documentation of the API you're using. Maybe you need to send a request first, and then you need to scroll through the response in order to see the types for all the data you have. So with GraphQL, you don't really have to do this, as we have the schema, which forms the source of truth for our API. And what I'd like to do next is compare the type systems, because you can imagine there's lots of familiarities in there. So on the left, you can see Typescript, probably looks familiar to you, and then on the right, you can see GraphQL. The syntax is pretty much the same. There are some small differences, like the way you actually define the type, and then there's some more differences. But both have like basic types. So in TypeScript, we like to call the basic types the everyday types, like a number or a string. And in GraphQL, we call them basic scalar types, which is like an integer or a string. ID is one as well. We have float, so that's kind of a funny one. In GraphQL, there are multiple ways to define a number. You could have an integer or a float, maybe if you have decimals. Whereas in TypeScript, everything will be a number itself. And then they can also relate to other fields, which is kind of similar to the way we do things in TypeScript as well. The notation in GraphQL, there's actually only one way to define an array, while in TypeScript there are multiple ways to define an array. But it looks pretty familiar. You can also see that in TypeScript, all the sort of types, they are lowercase, whereas in GraphQL we use an uppercase. And then the biggest difference actually is that in TypeScript, most types should be required by default because you want to make sure that your types are there. Whereas in GraphQL, most of the types are actually optional. And this is because one of the fundamental concepts behind GraphQL is people like to reuse the GraphQL API for different use cases. So maybe your GraphQL API is being used by one application from one team, and then the other team is also using the same application, but they're using your queries in a slightly different way. So maybe they like to get only a title and a thumbnail, while a different team maybe focuses on categories and reviews. So in GraphQL, everything's optional, and in TypeScript, it's required. And this is important to know when you start to combine the both type systems, because otherwise you might go crazy if you think something is returned by the GraphQL API and then it's actually optional, meaning that in TypeScript you you actually have maybes in your types, which is something I like to prevent when working with TypeScript. So that's the biggest difference. And in GraphQL, there are some libraries to actually help you with combining TypeScript and GraphQL, because you can imagine it will be a pain in the ass if you have to create types for every GraphQL query you're using. It sort of goes against having a type system in GraphQL and then still need to manually type your types in TypeScript. It feels like a lot of duplication, and I usually try to avoid this because as soon as you start duplicating stuff, you probably introduce errors. So this is something we like to prevent. And in GraphQL, there is a library called GraphQL Code Generator. It's been around for quite some while, and quite recently they sort of revamped the library, took away a lot of the things it did, but also introduced new stuff, which is actually better. The old way of doing stuff was with like configuration in YAML, and if you're a JavaScript or TypeScript developer, YAML could be quite confusing. So you can use GraphQL Code Generator to generate types for your GraphQL API. So if you're interacting with a GraphQL API, it doesn't actually matter how the GraphQL API is built or who's maintaining the code. The only thing you need to do is like making sure you can get the schema, and you can always get the schema via a operation, via introspection query. So GraphQL Code Gen is a CLI tool, and myself, I'm actually a fan of building stuff CLI first. So at my company StepStem, we also decided to build CLI first. And it's also cool from GraphQL Code Gen that they have a similar approach. Because as a developer, you already have a terminal, so why should you go to some GUI or whatever to figure out how your code works? It's also useful if you try to integrate it with like a CI/CD. So you can imagine every time you create a new project or you create a new build of your project, you probably also want to take the GraphQL schema, maybe regenerate some TypeScript types if the data has changed. So being it a CLI tool is actually helping you to put this sort of step into your workflow. So if you remember both the type definitions, we have TypeScript and GraphQL. And using the GraphQL schema as a sort of truth, by actually flipping it, we can generate TypeScript types from your backend. So as a front-end developer, you wouldn't have to create these manually. Instead, you just take the GraphQL schema, and then you're able to generate types on the fly. And it looks a bit like this. So if you remember, we have the basic scalars in GraphQL. If you would map those to TypeScript, you would see something like we have on the left. These are like the basic scalars. So we have ID, string, boolean, integer, and float. And as I said, we have two ways of doing numbers in GraphQL. So we have both integer and float that would map to numbers in TypeScript. And then you can also define types for every type you have in your GraphQL schema. So this is an example for the type product. You can see the first field, which is a _type name. So this is whatever GraphQL uses to define the name of this type. So it's actually really useful if you're working with GraphQL clients or you're trying to cache things somewhere. It will usually take this type name to make sure it doesn't duplicate it. And the way you define relationships within your type system in GraphQL and TypeScript is pretty much the same. So you can actually just copy these if you're working with TypeScript and GraphQL. And this way you can actually achieve end-to-end type safety, which is, well, a major reason, especially if you're like a full stack developer. You probably are looking for end-to-end type safety because I feel it's often like the holy grail of like web development. If you're building full stack apps, you want to make sure that whatever is happening on your backend will be in sync with what you're doing on your front end. And type systems are really important in that sense. So let's try it out. I created a React application, and then we can use GraphQL Code Generator to actually generate the types for us, which is quite convenient because that way we don't have to rely on some backend team to do it for us. Let me see. Where's my code? It is here. So I've created a GraphQL API, and then I've set up Code Generator to work with this. If you went to the workshop yesterday, it might be a bit boring because you already know how this works, but maybe you can also help me and tell me if I make any errors somewhere. So I've created this GraphQL API. It has a few types, basically like articles, because I created this sort of Hacker News clone, including some, well, what it does, this Hacker News clone, it's basically a GraphQL. It uses a GraphQL API that will take the latest posts from Practical Dev and then renders them in this feed. So if we would go to the most recent post, it's actually an interesting one because maybe people should actually stop introducing more machine learning models beyond GPT-4 because it could be dangerous, potentially. But this data is coming from GraphQL. And in my application, I want to make sure that this is type safe compared to the data I could request from my GraphQL API. So the way I've set it up, I'm using GraphQL Code Generator right here. And I use it to take my schema coming from this GraphQL API. And what I want to do, I want to generate code for this Typescript file. So I have just a simple component that renders my article. And as you can see here, I don't know what my types are yet. So you can see everything is basically any. So I don't really know the type of my article. What I of course can do, I can manually type this. So what I could do is trying to figure out, so this is my query. I can probably create types from it. It's quite an intensive process, especially if you start changing things. So as this is TypeScript, I could just start typing like type article props. I probably like to call them article type. And then you probably need to have every field, right? So we have a ID, which is a string. I can have Copilot help me, which is actually convenient. So these could be my type definitions. And then I probably need to link this up here. So this is one way to type it. You might get some error. I'm not sure why. So this is a string and the other one is a number. So maybe I need this. Yeah, so this will solve it. And by typing this is actually fine. You can do this. But imagine maybe you have 100 components. Maybe you have 200 components. Or maybe someone decides that we don't really want to use this kebab casing for body HTML, so we change it into like a camel case, body HTML like this. Or maybe someone in the GraphQL API side, they decide to make this optional, and you're using the body HTML to render something, and suddenly it becomes optional and it can break your TypeScript code. So I like to prevent these kind of situations because it's just unneeded. It will lead to like code reviews that might get stuck somewhere because someone changed the API. And if you don't work on the API, you probably don't even know that something has changed. There are libraries to help you getting notified when someone changes the GraphQL schema, but it also feels like additional overhead. So instead, what we can do with libraries like GraphQL Code Gen, we can auto-generate this code for us. So to run GraphQL Code Gen, you need to install some libraries. As I've already did. Might make this a bit bigger. And then you can just run GraphQL Code Gen itself. And as I told you, it's a CLI-based tool. I can just run it once, and it will generate outputs for me, which is basically a file containing all the types for my GraphQL schema. So if I would go here, I can find a new directory called GQL. It contains my fragments, if I have any. And it also contains some documents, which I didn't really add in here, but I will do it in a bit to show you more added benefits of using this tool. And then this is like the main file, and it contains all the types from our GraphQL schema. So you can see we have an article type, and it's a type I was using before. So what I could do here, instead of having this article type, I could just import article. Oh, GitHub Copilot is trying to be funny. I can do article and rename it to article type. So I don't get any conflicts with the name of my component. And then I should import this from the GQL file, which is probably here. And then I had a file called gql.ts, so this should be good. Or maybe it's in this file. No, it's in this file. Call this GraphQL. And I want to do this. So this will also give me a type. So now I get another error because this could be undefined. So I need to add some additional checks, which is all fine. And this actually is a number now. So I actually mistyped it already the first time. So you can see how error prone it is. So this is all good. I can see it's like maybe a string. So that's why I'm also giving like an empty string, because this one is expecting the string, which is not optional. So this is all good. And I can run this GraphQL Code Generator every time someone makes changes to my schema. But then there's a second variable in this, and this is actually the queries you use. So maybe I'm adding additional fields here, and I don't want to use this article type because it's like the global type which contains all these different types. I probably want something more specific to this component, because maybe even I'm like combining multiple types in here, or maybe I'm using a different GraphQL client like Relay, which kind of helps you to co-locate fragments all over your application. So there's a second variable, which are the documents. So what I can do to get the documents in here, I can actually create a second file. And I probably just, it doesn't really matter where I do this, I can just do it in source. And I will name this file something like operations.ts. So this is another file where I would put all my operations, such as this one. And I can then import GQL from this one to actually keep using the template literals with some GraphQL syntax highlighting in it. And what I can do then, of course, I need to import this one here. So I can do import name of my query from the operations file. And then this all should remain working. I still have my article type here, and actually nothing has changed. But what I can do with CodeGen, I can also link up this document containing all my GraphQL queries. So that way, whenever I make a change in some of the queries that I've defined in my application, I can also generate types for this, including types for the variables I have in there. So I can just save it. I can run the code generator again. But what I like to do this time is actually using the watch mode, meaning that if I make changes to any of my documents, it will actually redefine the types for me. I can run it again with watch. And now it will actually watch for changes. So not only do I now have specific types for my document, which will be in somewhere in here, probably be at the bottom. So yeah, I have like actual queries now with some documents in it. And what I can also do is now have the watch mode. So if I would start making changes, oh wait, I actually need to call this TS. Let me run the watch mode again. So I made a change in the config. And now I should be having, yeah, so that was what I was looking for. So the second file, like gql.ts, it will contain my documents, meaning that I will get specific types for the queries I'm using in my code. And every time I would make changes here, so maybe I'm adding new fields like upvotes, and I would save it, you can see the generator is generating a new output. So now this file should also have upvotes in it, as you can see there. And this helps me a lot, because if I would go back to my article, the way I typed it here is a way I don't really like. Instead, I can also use generics on my use query, which helps me to type two things, because the input of my use query hook is both the query, but also the variables. And in here I could use this generics here. Is everyone familiar with generics in TypeScript? Yes, lots of you are, so that's good. So it's actually a really nice way to reuse type checking without having to statically type all the things every time. So my use query actually has no idea what type of types I'm putting in here. And what I can put in here are the specific types created for my document. So I would be going here. I should be able to find them somewhere, or actually in here this time. And my query is called get, oh, I need to search here. It's called get articles by ID. So these are my variables, and this is my actual query. So I can use this with a generic and import it, of course. Let me see, it does automatically. And then the other one was called get article by ID query variables. And these will be updated every time I add new fields in my document. And then if I would go down here, I see I get an error here because this could be undefined. So it also helps me to to type my variables like this. And this should all be good because the generic is making sure the types are sort of pushed down to all the places where I'm using my GraphQL data response. And every time you add new fields, you could just have the watcher on. So you'll typically do this when you're in development mode and you're building your components. And it's a really convenient way to make sure that whatever you have in your application is synced with the GraphQL API you're using. So that's how you use React together with GraphQL Code Generator to actually get some magic in there with the possibility of having end-to-end type safety. You can also use Code Generator for like backend projects. So if you define your GraphQL schema somewhere, you could run it against the schema to get like types for your resolvers. You can also use it with basically anything that's using TypeScript, so it doesn't have to be React. It can also be Vue, Svelte, or whatever front-end framework you're possibly using. So then the question, if you start converting everything to TypeScript right away, well, as most of you are already doing TypeScript, you probably should, because if you're familiar with it, just do it. If you start to go from JavaScript to TypeScript in a project, make sure to do it one by one, because if you start adding TypeScript to the entire project all at once, you probably run into errors. One thing that actually helps you is most of the sort of modern front-end frameworks. They will allow you to have both JavaScript and TypeScript files in the same application. So it really helps you to do this migration one by one, instead of doing this sort of hard migration where you change everything at once. But most of all, maybe if you're not starting to use GraphQL on the backend system, make sure to introduce some sort of type system. So there's also good alternatives for GraphQL if you're trying to get a type-safe system. You could, for example, use gRPC if you want to stick with a sort of more REST approach. But what I really would like people to take away from this talk is start introducing type systems in all your projects, because they will make your life a lot easier, especially if you are planning to work on this project for a longer period of time, or maybe you're not coding every day and you want to make sure that every time you revisit the project, you don't have to put all this work in to actually know what your data looks like again. So that was my talk. I hope you enjoyed it. If you want to stay in touch, you can follow me on Twitter or find me at the conference. Thank you.